Here is one important question. The question is memory based and it is given into 28 December 2023. That means today, linear algebra and matrix theory question. Here the question is here x and y be to n cross in matrix such that xy equals to x square plus x plus I, where I is an identity matrix and which of the following are true. X is invertible matrix. Here we recall some basic facts, in linear algebra, especially in matrix theory. Let X be an n cross n matrix such that determinant of X is non-zero. Then we say X is invertible. X is invertible, or we can write the fact det x is non-zero if and only if X is invertible matrix. So here what is the relation? Here the relation is given. Here the relation is given. So the given relation is xy equals to x square plus x plus I, given x square plus x plus I equals to xy. So that we can write xy minus x square minus x equals to identity matrix. So x is basically pre-multiple by x. So y minus x minus I, this is equals to identity. So we take the determinant on both sides. So det of x into y minus x minus I equals to determinant 1 equals to date of identity. So that means date of x into date of y minus x minus I, this is equals to 1. So that means determinant of x is basically non-zero and hence we can say x is invertible. So by the above fact we can say x inverse exists. So x inverse exists and hence option is correct. Now for option B, if we take x equals to just simply minus identity matrix, so then I plus x, that will be null matrix, and in that case date of I plus x is equals to 0. That means y plus x is not invertible. So option B is false. Now we'll move to option C. Option C, xy equals to yx. So here you will see what is y. From that we can say since since x inverse exists and x inverse exists as determinant of x non-zero and x square plus x plus I equals to xy. So x inverse, we just pre-multiply by x inverse on both sides. So x square plus x plus I. So that means that will be x plus I plus x inverse by I apply an associative law. So what will be your y? Your y is x plus I plus x inverse. So this is our y. So in that case, we just calculate xy. So this is x square plus x plus I, and yx, y means x plus I plus x inverse x. So this is x square plus x inverse x, that means identity. So what we proved? We proved xy equals to yx. So that means option C is correct. Now we'll go to the option D. For option D, take option D, take x equals to -1, -1, 1, 0, and in that case y equals to x plus I plus x inverse. So and x is -1, -1, 1, 0 plus 1, 0, 0, 1 plus x inverse. So here x inverse, that means 1, and that will be, so what will be the inverse of the matrix? We will calculate here. So we have to recall another important fact. If A equals to ABCD and A is, and determinant of A is non-zero, so here A inverse, that will be 1 by AD minus BC DA, that principal diagonal interchange, and that is multiple by off diagonal multiplied by minus sign. So here the determinant is 1. So that will be 1 by 1 dA. So that means 0 minus 1. Just we multiply by minus 1 here. So that will be 1 minus 1. So here we add all these matrix. What we will get? Minus 1, 1 plus 0. So this will be 0. That will be 0. This will be 0 and 0. So y is basically the 0 matrix, and hence date of y is non-zero. So date of y equals to 0, and hence y is not invertible. In that specific example, if we take x equals to this 2 cross 2 matrix for n equals to 2, so y is not invertible matrix. Option D is false. So our answer is A and C, that is true, while B and D are false. Thank you so